Hello everyone, we're now starting Unit 6 Part 3, and this whole unit is about solving quadratic equations, so specifically quadratics and not the cube things to the third degree or fourth degree or fifth degree. We're just going to stick with quadratics and we want to be able to solve them. And if you remember from when we graphed quadratics, when you graph them you end up with a parabola. And so when you're solving the quadratics, what we're really finding are the zeros, so those x-intercepts. We're finding those numbers of our polynomial. So when you're solving the quadratics, you're looking for two x values, and those x values are the numbers you could substitute in your equation, and you would get 0 as an answer. So solving means that we're trying to find the x's that will make our equation equal 0, and in turn, you're finding the two zeros of your polynomial. So you learned how to do that graphically before. Now we're going to learn how to find it algebraically and get our exact answers. And there's many different methods to solving quadratics depending on what type of equation you're given. Okay, so for this first section, assignment 11, we're going to solve quadratics by using square roots. And this type of solving only works when the quantity that's being squared can be isolated. And what do I mean by that? Well, I'm saying you have to be able to get the x squared or something in parentheses squared. That's still a quantity because we're grouping that whole thing together. You have to be able to get that totally by itself. So if you have a term with an x in it, then you're not going to be able to. If you can only have a quantity squared, so either a variable just squared by itself or something in parentheses squared, and then a constant or a number on the other side. Otherwise, you're going to have to use a different method of solving, which we'll learn in the next few assignments. So that's the first thing you have to look at is, can I actually use the square root method? The second thing is that once you've identified you can, you want to isolate that quantity being squared. So you want either x squared by itself on one side or something in parentheses squared by itself. Once you've gotten that, then you can actually square root. And if you remember back from geometry, once you've taken your square root, then you're going to end up with wanting to simplify your radicals. So we're going to keep all of our answers exact, which means avoiding changing them into decimals unless we need to use them to graph, but we want to keep them exact, so you're just simplifying your radical, and I'll refresh your memory about how to do that in the next couple slides. So the first one is relatively basic. So the problem we're given is x squared is equal to 49, and we want to think about those things we just talked about. Well, the quantity squared, which happens to be x squared right now, that is already by itself. It's alone on one side. And there's no other term that has an x in it. So if this equation were instead x squared plus 4x is equal to 49, then we would not be able to use the square root method because of that 4x right in the middle. So because we just have an x squared and a constant, we're all set. The second thing said to isolate your variable or your quantity squared, but we've already done that. X squared is by itself on the left-hand side. So you want to isolate it, which we've done. As long as you've taken care of those two things, then you can go ahead and take your square root. And in this case, the square root of 49 is an actual number, not a decimal, so a whole number, I mean. So we get an answer of 7. The square root of x squared, well, the square root and the power of 2 are opposites, they're inverse operations, so they cancel each other out, leaving us with just an x. But if you remember, when we graphed a parabola, there were two potential spots where our graph could cross the x-axis, right? So whenever you're solving solving a quadratic function, you would hope to get two answers. You could potentially get one answer, which would just be two numbers that are exactly the same, but you're still getting two values out of that. Or you could get a complex root, which means that it's going to float up above your x-axis or down below, and you get no real answers, but again, you would still see two different things when you were solving. And we'll sort of check out those issues as we go along. So what I'm getting at here is that when you take a square root and you're solving a quadratic, if you start from x squared, remember that you not only get positive value of 7, but you also have a negative value of 7. So every time we get our answer to solve a quadratic, we're going to use plus or minus 7, which means that we have a positive 7 and a negative 7 as our answer. And the reason that works is because I can square 7 and get 49, or I can square negative 7 and get 49. So both of those answers, positive 7 and negative 7, are possibilities. Alright, so in this next example here, we have our quantity squared, x squared. This can be isolated because there's no other x term. These are just numbers. So we can get this by itself, and that's going to be my first step. So I'm adding 72, and I get 2x squared is equal to 72. And then I want to get x squared totally by itself before taking the square root, so divide. So x squared is equal to 36. Now that it's been isolated, you can take your square root, and so on the left side we get x, and then the square root of 36 is going to be positive or negative 6, so plus or minus 6 is what I end up with. And you can write it just as one value like that, plus or minus 6. That tells you you have two answers. Alright, so for the next one, number 3, again, you can isolate x squared because these other two are just constants. So in order to do that, I need to divide by 2, and we get x squared is equal to 32. Then I can take my square root, so on the left I'm left with x, but on the right hand side, up until now, we've had numbers like 49 and 36, which are perfect squares. When you get a number like 32, there's no actual square root of that. That is a whole number. So that's where you need to take your skills that you learned in geometry. And if you have the square root of 32, you want to break that down so into its factors. So I know that 2 goes into 32. It's 2 times 16. 16 is 4 and 4. 4 goes into 2 and 2, and 2 and 2. And so you're breaking it down into all of its prime factors. And then you want to look at those factors. And if it's a square root, so there's sort of an imaginary 2 as your index out there, then you want to look for groups of 2. So I have one group of 2 numbers that are the same is what I'm talking about, what I'm looking for. I have another pair of numbers, group of 2, and then I have this last prime number that has no match. So he's sort of left out in the cold, left on his own. And if you have a pair, you can take that number and make it into a whole number because the square root of 2 times the square root of 2 is the whole number 2. So from this pair, we get that 2. From this pair, we're going to get another 2, and because this is a factor, it's all multiplication. So these can come outside of your square root, and then anything that's a single is going to go back inside your square root. And if you had more than one, they would be multiplied. So here you end up with 4 square roots of 2, and don't forget we always have the plus or minus. Another alternative to simplifying your square root is if you guys are good at recognizing perfect square numbers, you would notice in the beginning that 32 is the same thing as the square root of 16 times the square root of 2. And the square root of 16 is really just 4. So you get 4 times the square root of 2, or 4 square roots of 2. If you don't recognize that, then just do your factor tree out and you'll get the same answer. All right. And lastly, when you start to get a value that doesn't look just as simple as x squared, it changes a little bit, but not too bad. So we still are looking at the fact that this right here, parentheses, they're grouping the x minus 3 together. So this whole thing is a quantity that's been squared, and we can isolate that. And as long as you can isolate what's being squared, you can take the square root. So my first step here would be to divide by 2, and you're left with x minus 3 squared is equal to 64. And then from there, now that these parentheses are by themselves, you can go ahead and take your square root. And the square root and the square, they cancel each other out because they're inverses. So all you have left is x minus 3. So you don't want to actually square what's in the parentheses here. You're not going to get x squared minus 9 because you would really have to FOIL this whole thing out. So we don't want to go that route because we're trying to solve it. So keep it as its factor and just take your square root, which cancels out this power of 2. And so if they cancel, all you're left with is the x minus 3. And then on the right-hand side, we have to think, okay, well, what's the square root of 64? Well, it's 8, and also we have plus or minus 8. Your last step is to actually solve for x, so add 3. So x is equal to positive 3 plus or minus 8. But remember that plus or minus is really two different things. It's giving you two different answers. And since this is a whole number, we can actually figure that out. So this would become x is equal to 3 plus 8, and x is equal to 3 minus 8. So here we get 11, and here we get negative 5. Alright, so go ahead and try assignment 11. Make sure you're simplifying your radicals. Check your answers when you're done.